while reducing the toxicity and volume of the final waste by reclaiming materials contained in spent nuclear fuel that can be recycled. Areva, La Hague site, world leader in high technology.
A load of spent fuel assemblies are arriving at the Valognes rail terminal, situated at 20 kilometers from Cherbourg. They're protected by a watertight steel package called a chateau or cask. It weighs 110 tons for 10 tons of spent fuel. This positive strongbox is mainly designed to resist temperatures of more than 800 degrees Celsius and can be dropped from several dozens of meters. The road convoys between Valognes and the La Hague plant originate from one of the 58 French nuclear reactors, or reactors belonging to overseas electricity companies. One hour, 10 minutes after leaving the Valognes rail terminal, this unusual road convoy arrives at the La Hague plant entrance gates. In the receiving and dry unloading facility control room, engineers go about unloading a spent fuel assembly. This one assembly produces the energy equivalent of 27,500 tons of oil.
96% of the material contained in the cladding of this fuel can be recycled. 95% is uranium, 1% is plutonium, and only 4% is fission products or waste.
On the other side of these windows, which are 1.20 meters thick, the removal of the fuel rods from the assemblies is monitored from the control room. The assembly, still at a temperature of approximately 200 degrees, is cooled initially in water and checked prior to being placed in a basket. This basket will be set down in one of the 4 reprocessing site pools. This 500 kilo spent fuel assembly is carefully set down at a depth of 9 meters. It will stay in the pool, where it will continue its decay process prior to being treated. In the plant's control room, engineers carry out the actual treatment process by remote control. First of all, the fuel assemblies are sheared in accordance with an automatically controlled process. Only a few operating and maintenance operations require human intervention. These interventions are carried out by means of manipulators. Using remote manipulation, tools and materials can be handled by remote control, making it possible for the staff to operate under optimum safety conditions, as they are never in direct contact with radioactive material. In the shearing facility, the cladding containing the spent fuel is cut up into segments. These 3-centimeter segments fall into a tank of hot nitric acid. The nuclear material is dissolved in this solution. The pieces of cladding called hulls are removed so that they can be compacted. The nitric acid solution containing the dissolved nuclear material is automatically transferred from the control room to the chemical separation facilities. Uranium and plutonium are separated and purified. The plutonium is recycled in the Melox plant to manufacture new MOX fuel. This will feed nuclear power stations for further production of electricity. Uranium, on the other hand, is reused for manufacturing nuclear fuel or transformed into a stable oxide in order to build up a stock of energy materials. The final residue or waste is to be solidified here in accordance with an extremely safe procedure, vitrification. From the vitrification facility control room, the fission products are calcined and then incorporated in a glass matrix, trapping the radioactivity and preventing it from spreading. This mixture is then poured into stainless steel containers. The proven chemical stability of this borosilicate glass, which is used to immobilize the fission products, constitutes an international consensus concerning the qualities of this matrix. This solidification guarantees watertightness and stability for hundreds of thousands of years. Hulls and end pieces are compacted by means of a press with a 2,500-ton capacity. These materials from spent fuel shearing are compacted and their volume reduced to 1/5 of their size. The result? The treatment of 1 ton of spent fuel generates less than 0.4 cubic meters of final residue. Owing to the volume reduction, the surface area for final waste interim storage for 40 years of French nuclear electricity does not exceed that of a football pitch. This optimization also makes drumming safe and makes interim storage easier. Moreover, the use of standard containers makes the handling and transportation of residue easier.
The knowledge and technical know-how acquired here are internationally recognized.
French waste is temporarily stored on the La Hague site. As for waste from overseas spent fuel, it is returned to its country of origin in accordance with French law. There are approximately 4 to 5 transportations of vitrified waste that leave La Hague each year. The containers are subjected to a final quality check carried out by the specialists prior to being returned to the customers. On the other side of the world, in the north of Japan, a load of vitrified residue from spent Japanese fuel in La Hague is arriving at Rokasho-Miura. During this time, one of the roundsmen inspects a vitrified residue interim storage hall. Each circle on the ground corresponds to a pit holding 9 containers of vitrified products. Waste corresponding to approximately 5 years of activity by French nuclear electricity equipment is temporarily stored in the pits in this hall, under the roundsman's feet. All employees working in controlled access areas have to wear dosimeter film, which measures radioactivity in real time. Hands and feet are checked to ensure that they're clear of radioactivity every time a member of staff leaves the facility. Control equipment, preventive measures, medical monitoring, nothing is left to chance as regards the protection of the employees in the face of radioactivity. The La Hague reprocessing site, stretching over more than 741 acres, is permanently monitored by a team of 200 security officers, control systems, cameras, and electrified fencing.